Hello, I'm Dane, and this is Dane Explains. Recently I did a couple of videos on the definition of different types of bodies in our solar system, namely planets and stars. It reminded me about a group of people who wanted to call all round bodies in the solar system planets. So that means not just the planets we know like the Earth and Mars, but also moons like our moon. But no, not Mars's moons. Sorry guys, you didn't make the cut. Well, one thing I think those people are missing is that we already have a word that closely fits the definition for all those types of bodies. So, what in the world am I talking about today? The title and thumbnail may have given you a hint. Worlds, of course. Specifically, worlds in the astronomical sense. Not in the theological, philosophical, or even cosmological sense. And yes, those all have their own definitions. Maybe I'll talk about them in some other videos. So, planets, moons, asteroids, stars. What in the world is a world? Let me explain. What do you think of when you think of the word world? What comes to my mind is some kind of body that's generally easily traversable by human beings. Well, it's pretty simple for a general definition. It doesn't quite cut it for classifying astronomical objects. Let's start at what we all agree is a world and work our way out. We often use phrases like what on earth and what in the world interchangeably. And we often refer to the earth as the world. So when I think about the word world, what comes to mind is the earth. So if there was an object that was prototypical for the word world, it would definitely be the earth. However, there isn't actually a good definition for what a world actually is. So, let's try to clear this up. We all obviously agree that the Earth is a world. I think it's also obvious that the Sun and a space rock the size of a truck are not worlds. So, we have some bounds to work with. In light of that, let's try to narrow it down. It seems logical that Mars would be a world too. The only thing it lacks compared to the Earth is an atmosphere that's life-sustaining. What about Venus? It seems like a world. An unpleasant one, but it's actually trickier than it seems. More on that in a minute. I think most people would also describe the moon as a world too. Besides that kooky minority of astronomers who seem to have forgotten the word world exists. And no, the moon is not a planet. Sure, you need a spacesuit, but you would on Mars too. What about Jupiter or Saturn? Now we're getting into an area where sane people disagree. Unlike Earth, gas planets like Jupiter and Saturn have no surface. Now, that might sound strange. I mean, they both have some rock, so they have to have a solid surface down there somewhere, right? Well, no. Unlike Earth, where there is an abrupt change from air to a solid or a liquid surface, large gas planets have no such surface. Their atmosphere just slowly gets thicker and thicker, going through what's called a supercritical fluid stage. Unlike regular fluids, supercritical fluids have no boundary between gas and liquid. It goes from gas-like to fluid-like, with no point at which you could call a surface. Eventually, the pressures as you descend to the gas giant far exceed the pressure you'd experience at Earth's core, and nowhere would you have bumped into a surface. They are still planets, however. So, a lot of people will still call them worlds. But since we already agreed, or not, that those two words are not the same, a gas giant is a planet, but not a world. Its structure and composition are closer to that of the Sun than it is to the Earth. It's just not as hot because it's not heavy enough to fuse any elements like the Sun can. I think a surface you can walk on or swim in is needed to be called a world. This is where the planet Venus gets tricky. Even though it's smaller than the Earth, its atmosphere is so thick it becomes a supercritical fluid near the surface. So how is it different from a gas giant besides its smaller size? Well, unlike a gas giant, it does have an abrupt transition from one phase of matter to another, from supercritical fluid to a solid. Gas giants have no such obvious abrupt change. So, I would propose that the upper limit for a world is a body that has a surface defined by an abrupt phase transition. So, either nothing to a solid or a liquid, or a gas or a supercritical fluid to a solid or a liquid. And yes, you could have an abrupt change from a supercritical fluid to a fluid. For instance, if the planet Venus was covered in an ocean of elemental mercury, it would be a liquid and still have an abrupt change between the mercury and the supercritical carbon dioxide. Speaking of abrupt, let's talk about how small worlds can get. This is probably even harder to define than the upper limit, because even space pebbles have a surface, and you can't walk on those, unless you're an ant anyway. The issue is there's a pretty smooth transition of characteristics from objects like space rocks to objects like Earth as you increase in size. All of them have gravity, some less so than others. The good thing is we'd have a lot of healthy discussion on the definition of small objects coming out of the "what's a planet" debate. One of the things that came out of that was that although the line is a bit blurred, asteroids are space rocks, or ice chunks if we're talking about comets, and round bodies are not. In astronomical terms, a round body is a body in hydrostatic equilibrium, which means a body that is roughly spherical due to the force of its own gravity. Material rigidity does come into play here, but I think that's an excellent lower bound for the definition of a world. That would of course mean that objects like Pluto, which the IAU has said aren't planets, would still be worlds. But I think that's fine because not clearing your orbit doesn't make an object not easily traversable by humans. Will that mean that some space rocks will end up being larger than some worlds? Yes, but if you think about it, my upper definition also has a fuzzy size limit as well. Let's think about what the goal is here: to precisely define an object by its physical characteristics that a human could potentially traverse. Not having any sort of surface makes that hard. What also makes it hard is having so little gravity that getting traction on the surface becomes a struggle between finding enough grip to move forward without pushing yourself off the surface. Where these lines fall exactly will depend on the person. So, what do I think is a good definition? A body which is large enough to have reached hydrostatic equilibrium predominantly due to its own gravity, but small enough to have a solid or liquid surface. Well, for some reason when I started this, I thought the definition was going to be much longer and more convoluted than that. I guess I can't complain. Thank you for watching. If you like this video, please press the like button, subscribe to my channel, and ding the bell to get notified when I post new videos. Also, please support me on Patreon, link in the description. The more people support me, the more time I can dedicate to making videos like this one. So, until next time, have a great week.